might need, for example, to define polygons. Maybe polygons. So this is when you're dealing with real projects. So you might face situations that are pretty much weird. Let's say this is our block model from a top view, right? Okay. So this is our block model, but maybe my mining rights or something like that. I have these mining rights. My block model is just over here. This is possibly something not valuable material, okay, not economic material over here. And I also will have these, for example, these mining rights over here. Or it could, here it's still rectangular, but let's assume, for example, I have these mining rights, and here I have some a new mining right that I will have in the future, and also, for example, I could have some restrictions, like here I have a community. And I'm considering a given radius to get distance from this community. So I want to constrain any mining in this circular radius. Okay. So the idea here is that you might need to take advantage of mining packages to design polygons, lines, curves, etc. to manipulate this grid of points. Okay. And then you will need to just project the points upwards or downwards, okay, as I said before. So you only need to play with the z coordinate, okay? The z can go upwards and downwards, but looking from the top, they should remain aligned with the block centroids, okay? So x and y might not be changed. However, when you are dealing with such circumstances of projecting points upwards or downwards on mining packets, it's possible that, let's assume you have the surface file over here, for example. It's possible that mining packages will create some points in between these ones, okay, to better make their wide frames, etc. I'm not sure if how much this is typical, but that's a possibility, and you should ensure you are using the proper formatting projection tools to ensure points are moving just along the z direction. Okay, so this is a tip and trick for you to avoid this situation in yellow, where the mining package creates additional points. And a thing that is related to the validation of such surfaces created by other software is the fact that, let's assume you have, for example, a surface file from another software, which is this one. Let's say it's this one, surface 1, and you will compare it to the topography surface from MiningMath. So this is a way to do a very quick validation of your surface. All you need to copy is the x and y values. So here I have the z from my topography, and here I have my y from my topography. Okay, and all I need to do is the verification. Actually, I need to do a x verification and a y verification. Okay, so all I need to do is to make a quite simple function over here, where x topography is x from equals to x from my surface. Okay, and I do the same for the y and replicate for the rest. So the idea here is that all values must be true for both fields, because x and y should be the same every time. Okay, if you have any false value, you should investigate that to see if it's a matter of setting, ordering or sorting properly the X, Y, and Z, like this, custom sort, expand the, continue with the current selection, and then add multiple levels, column A, column B, column C, from A to Z, everything. Okay, so you should analyze if that's the reason. Okay, then I would first suggest you remove these validation criteria and do it all over again. But it could also be the possibility of this sort of situation of mining packets creating additional points. Okay, when dealing with grid of points in other and their projection tools on these mining packets. I know that the proper tool, for example, MicroMine, the proper tool to do these projection only along the vertical axis, it's called drape. Okay, this is the proper tool on MicroMine. I don't know by heart similar tools to this one in other softwares, but if I get this information, I will share with you as well. Okay, so this is the main idea when dealing with some tips and tricks to always start with the topography file to manipulate that from use the topography file as a start point, and also when dealing with polygons to pay attention to this sort of situation, and also to take advantage of these quick validations, numerical validations, to see if X and Y are remaining the same. Okay, that's the way to even identify possible issues with your formatting. Okay, another thing, another issue that you might face, let's say tips and tricks, is when you need to transpose your grid. So when dealing with surface constraints, it's possible that, for example, here I have my project. You can see the origin is positioned in 0, okay, and it's possible that when you try to import a surface file from MiningMath like this one, it's possible that when dealing, let's say you have the system, the coordinate system in MiningMath is an index coordinate system, and the surface files are positioned in meters, but here it was on the origin, so the surface was here. Okay, this is it. So the surface was here in terms of 0 to something in meters. Okay, but when you import this surface file into, this is MiningMath, okay, and here you have a mining package where you want to manipulate these and to create polygons to select just a few points and project down or downwards or upwards, right? But then when you import these into the mining package, which could be, for example, using the UTM system, for example, the system of coordinates, it's possible that, for example, the block model will be here, right? We have the first block over here. And it's possible that our surface constraint, this one, will be interpreted as being here. So what you must do in this case is to take this first point, or along with all the rest, and move or transpose these surface points up to here. Okay, so automatically it would be aligned over here. And then when you want to import it back to MiningMath, you would need to do the opposite movement. Okay, you should go back to the origin of your coordinate system. So this is a very interesting trick when dealing with this integration of MiningMath and the mining package from the market. Especially useful for the subject of surface constraints. Another thing I wanted to share, let me see a little bit over here. topography, polygons, transpose your grid. Let me see what else I was intending to share. Bit design. Okay, this was the examples I were showing you directly at the interface of MiningMath. I believe when you fill these their origin with the proper values over here, this situation might be not needed. Okay, just I don't have certainty because I don't have access, fully access to all the mining packages all the year. But the next time I have, I will check that for you. Please feel free to let our support team to know if when you use the proper coordinates over here at the origin when importing your block model, if this situation is needed or not. I believe it's not needed. Okay, but I don't have certainty at this very moment. Let me see if I have something to share. Okay, that's it. That's all for now. I will possibly make more appointments on this point over here, dependent and concomitant goals, where you have possibly conflicting situations or where you need to combine surfaces from MiningMath to comply with different goals that are happening at the same time. Okay, when you need to mixture surface constraints, this is quite simple, quite straightforward, where you have multiple surface constraints to in different files, and you can simply add them in the proper field. But this is when you need to combine different things in the same file. Okay, so that's it for now. I believe we have covered plenty of situations to deal with surface constraints, and hope these can be possibly the ultimate guide on these complex but very interesting issue that can count on your favor for you engineers and mine planners to guide the optimization from MiningMath and to find more value for your projects as well. Okay, so that's it for now. Thank you very much for your attention, and see you on the next time. Bye.